Good morning, students. So now last class to discuss the topic is that is vectors and law of motion in a plane, xy plane. So today discuss the another chapter. So that is work, energy and power. Work, energy and power. So what is the work? How to define the work? And so what is the energy? And so the definition of the energy and what is the power? So now, first of all, so the discuss the topic is what is the work. Okay, so when conditions are, so work is taken positive or negative or zero. So first of all, what is the work? So work is nothing but here the force is, okay, so the force is applied on a body through some displacement, through some distance along the direction. Okay, and so magnitude of the force. Okay, so the force, okay, the force is acting on a body through some distance, some displacement along the direction, and so magnitude of the displacement is taken, okay, so this is called as a force, component of force, the product of component force, and so the magnitude displacement is called as a work. Okay, so what is the work? So it is the product of the component of force along the same direction, and S is the displacement or distance, the magnitude of the displacement or distance. So that is called as a work. And so here the suppose the force will be applied on your body and move through some displacement S. So now according to the definition, W is equal to F cos theta into S. So F cos theta is nothing but product of force. Okay, so product of force and displacement. So Fs cos theta, and in a right vector form. So W is equal F into S. F dot S is a scalar. Work is called as a scalar property. Now, so SI units of the work is taken joules or ergs. CJS units ergs. SI units joules. Okay, clear that? So now how to define the work? So work is said to be done. Now a force is applied on a body. Okay, and the product of component of force along the direction, and so S be the magnitude of the displacement. So that is called as a work done. Okay, so work done, in some more conditions is taken, work done, so positive or negative or zero. When theta is equal, so the theta is angle. So the angle is taken less than 90 degrees. Okay, so less than 90 degrees, theta is the angle, that is less than 90 degrees, is work done is negative. Okay, that is taken is positive. Okay, if in case of theta is greater than 90 degrees, so you are taken negative. Okay, work done is positive, work done in case is negative. So two more conditions are here taken. So once again repeat. So the theta is less than 90 degrees. Okay, theta is less than 90 degrees. So work done is positive taken. And so if condition the theta is greater than 90 degrees, so the work done is taken negative. Okay, so now if in some cases are taken, that is the force is equal to 0. When force is equal to 0, or displacement S is equal to 0, F is equal to 0 or S is equal to 0, or F is perpendicular to S. F is perpendicular to S. In those conditions, so the work done is so 0. Work done is 0. W is equal to 0. Okay, so F is equal to 0 and S is equal to 0. F is equal to 0 means so the force 0. So now here no force is applied on the body, work done will be 0, and so someone that is the case is taken, S is equal to 0. S is nothing but displacement is 0. So displacement is 0, so that is the force, that is the work done is also 0. So is taken wall, so some more force is applied on your wall. So the wall is not moved. So the energy will be lost, work done is 0. Okay, energy will be lost, but work done is 0. Okay, if in case of another case, F is perpendicular to S, F is perpendicular to S. So that is case is also work done is 0. Okay, so now right, next definition is energy. What is the energy? So capacity to do work is called as energy. Capacity, okay, capacity to do work is called as energy. Okay, so the same units are both units are equal to the work and energy. Okay, so the energy is nothing but capacity to do work is called as energy. So the energy is taken in SI units to joules or CGS units to ergs. Okay, so similar units are used both. Now, so another topic is what is the power? So power is nothing but rate of doing work. Rate of doing work is called as a power. Okay, clear that. So power is nothing but rate of doing work. Rate is nothing but taken time. So rate of doing work is called as a power. So it is measure units of watts. Okay, watts. That is the measure in a power. Watts power. Okay, so HP in this down. Horsepower. Okay, so here the taken power. So what is the how to define the power? So power is nothing but the rate of doing work is called as a power. So the capacity to do work is called as the energy. Energy. Okay, so clear that three definitions are what is the work, what is the energy, what is the power. Okay, so now discuss the another topic is so the energy. Energy is chemical energy or nuclear energies, okay, electric energy and so mechanical energies in a nature. So now discuss the mechanical energy. Okay, mechanical energy. So mechanical energy is taken potential energy and kinetic energy is mechanical energies. So first of all discuss the topic is potential energy. Potential energy. P dot E or it is denoted by U also. Potential energy. What is the potential energy and how to derive the equation of the potential energy? So that is the equation of the potential energy is mgh. Okay, mgh. M is the mass, G is the gravity, H is the taken height. Okay, U is equal or P dot U is equal mgh. Potential energy. So how to define the potential energy? So the potential energy, okay, potential energy possessed by a body, by virtue of its position or state, Okay, so that is called as a potential energy. So just for example is taken. So the water will be stored in a reservoir. Okay, so water stored in a reservoir. So stretched rubber. So many examples are taken in a daily life. Okay, so water will be stored in a, so for example bucket or like in a reservoir. So the water will be contain the energy is potential energy. So what is the potential energy? So the potential energy due to the position, due to the virtue of position or state is called as a potential energy. Okay, so number of cases are studied in a nature. So that is called as a potential energy. So the bullet is stored in a gun. That is also potential energy. Okay, so how to derive the equation of the mgh? So first of all is the taken one condition. So that is mass of the body is m is kept placed on the surface of the earth. Okay, kept on surface of the earth. So mass of the m of the body is placed on the surface of the earth. Now force is applied on a body. Okay, so required some force. So required to some force to apply on a body through some displacement, through some distance or height is taken, that is h. Okay, so that is the sum through the height is h, lift the body or lift the mass of the body. Okay, so here force is applied on a body which is equal to the weight of the body. Weight of the body. So that particular time, that particular case, so the body is lifted. Okay, so now first of all, so the body is placed on the surface of the earth. The body is placed on the surface of the earth. So mass of the body is taken m. Mass of the body is m. Now force is applied is equal to the weight of the body. Force is applied or required. Okay, force is applied or required to the weight of the body. Weight of the body. So weight of the body, that is the W is equal mg. Okay, W is equal mg, and that means the force is equal to the weight of the body. That particular condition, the body is a lift. Okay, so the body is a lift vertically through a height is h. Okay, clear that? So according to the definition of the work done, so the work done is equal to force into displacement. According to definition of the work done, so the W is equal force into displacement. So the force here, applied force is equal to the weight of the body. So that F is equal to mg. And through the height, S is equal to h. So W is equal mgh. So next cos theta is taken in before case. So cos theta is nothing but here 90 degrees. So cos 90 is equal 1. So that is not taken. So W is equal mgh. Okay, W is equal mgh. F is nothing but the force will be equal to weight of the body. So weight of the body is taken mg. So W is equal mgh. So the W is equal mass weight of the body. So that is the total work done. So W is equal mgh. So that will be stored in a potential energy in a object. Okay. So W is equal, that is the total work done. So the total work done will be stored in a object in a form of potential energy. So the potential energy U is equal mgh. Okay, so the potential energy is denoted by the U. So U is equal mgh. So units of energy or potential energy or kinetic energy work done, total units are equal, or joules or ergs. Okay, clear that? Got it? So first of all, what is the potential energy? The energy possessed by a body. The energy possessed by a body by virtue of its position. So by virtue of its position or state is called as a potential energy. So the equation of the potential energy U is equal mgh. So now consider the object is placed on the surface of the earth. So some more force is applied on a body through some distance h. So the force is equal to the weight of the body. So according to the definition of the work done, so the W is equal F into S. So the W is equal F into S. So W is equal F is nothing but mg and displacement is taken h. So the total definition is taken U is equal to mgh. Okay, so the total work done will be stored in a potential energy. Okay, so the next one definition is taken kinetic energy. Okay, so what is the kinetic energy? So for example, so the bullet is stored in a gun is called as a potential energy. So the bullet is fired from the gun. So that is called as a kinetic energy. Okay, kinetic energy. So motion of the any object is taken, that will be contain the kinetic energy. Okay, possess the kinetic energy. So the train is in motion, the bullet is fired. Okay, so many examples are taken to the kinetic energy. What is the kinetic energy? So the kinetic energy is possess the body. Okay, by virtue of its motion. By virtue of its motion is called as a kinetic energy. By virtue of its motion is called as a kinetic energy. So the definition or derivation of the kinetic energy. So K dot E is equal of mv square. Kinetic energy is equal of mv square. So what is the m? M is nothing but mass of the object. Mass of the object. So what is the v? V be the velocity of the object. So the kinetic energy equation we can write. So kinetic energy K dot E is equal of mv square. Okay, of mv square. Now derive the kinetic energy equation. So now first of all taken the diagram. So here taken mass of the object is m. Okay, that is the rolling body. Consider the rolling body. So initial velocity u is equal to v taken. So the body is rotating through the some displacement. Okay, in s. Okay, clear that. And so the final velocity of the body is taken 0. Final velocity of the body is taken 0. So now we consider the mass of the body m. So initial velocity of the body u is equal to v. Why have taken u is equal to v? Because the body already in motion. Okay, so the body already in motion. So that is taken initial velocity u is equal to v. And so the final velocity is taken v is equal to 0. Okay, through the some displacement s. So initial velocity u is equal to v and is in motion or is moving. So after some distance s, so the body is bring to rest position. Bring to rest position. So that velocity is 0. Okay, so by using the kinetic equation, v square minus u square is equal to 2as. Okay, so here taken, so v is equal to 0 square, u is equal to v, and substituting in the equation. Okay, and 2, a is nothing but is taken acceleration, s is taken displacement. Okay, got it? And so minus v square is equal to 2a as a is equal to minus v square by 2s. That is called as the acceleration. So acceleration a is equal minus v square by 2s. Okay. So by using the kinetic equation, v square minus u square is equal to a as. So v square final velocity should be taken 0. Bring to rest position because. And u is equal to v taken, a is called as acceleration, s be the in some displacement. So a be the acceleration, a is equal minus v square by 2s. According to the definition of the Newton's second law, F is equal to ma. According to Newton's second law, F is equal to ma. So F is equal to ma. So a value is already we know that is acceleration. So substitute in the equation m v square by 2s. M v square by 2s. Now this is called as the force. Okay. So here some many force is applied opposite to rolling body. Okay. So some force is applied to oppose to the body, bring to rest position. Okay. The rest position in displacement s. So bring to rest position according to the Newton's third law. Action is equal minus reaction. Force is equal minus F. So now here applied force. So that is taken action is equal minus reaction. So F is equal minus into so minus mv square by 2s. Okay, F is equal minus into minus mv square by 2s. So F is taken plus mv square by 2s. Okay, so F is equal plus mv square by 2s. Here taken action. Okay, so that is the opposite to some force is applied through into rest portion is called as the reaction. So F is equal minus F according to Newton's third law. So F is equal minus into, so minus mv square by 2s, so F is equal plus mv square by 2s. Okay, according to the definition of the work done, so W is equal Fs. So the W is equal Fs, so F is taken mv square by 2s into s. Okay, according to the definition of the work done, so work is equal to force into displacement. So the force is taken substituting and displacement is also substituting. So displacement S and S are cancelled. So remaining equation we can write of mv square, of mv square. This is the total work done. Total work done. Okay, bring to rest position. So the W is equal of mv square. So total work done will be stored in a kinetic energy. So that is the K dot E is equal of mv square. So the kinetic energy, total work done will be stored in a kinetic energy. So K dot E is equal of mv square. Okay, so now to discuss the another topic is law of conservation of energy. Okay, so discuss another topic in a next class. Okay, so what is the kinetic energy? What is the potential energy? Today completed. So what is the law of conservation of energy? Okay, what is the collisions? So discuss the another class. Okay, thank you, students.